So, function notation. First of all, start out with a little bit of review, a little bit of recall, a little bit of remember. So remember, domain is just all the blank values. Which values are the domain? X values. That's a terrible X. Let's try that again without my pen kicking out halfway through. All the X values, all the input values. Range is all the Y values, all the output values. Oh, and remember when finding domain and range, we have two types of relations. The ones that are individual points on the grid and the ones that are continuous lines on the grid. Do you remember the word that was describing individual points began with the letter D? Discrete means they're separate. Do you remember the word that we used to describe graphs that were continuous with no gaps? I'll give you a hint. It rhymes with continuous. It's meant to be really obvious. It exactly rhymes with continuous. We actually call them continuous. Greg got that joke. The rest of you. In other words, Amber, the first graph there of those four is discrete. The other three are continuous. Simi's ticket question earlier was discrete because you can't have 2.6 tickets. For each of the following, state the domain, range, and whether or not it's a function. Okay. Domain. For a discrete one, you list them. Someone want to rattle this off to me? Amber, what's the domain? Can you do it? Starting on the left, work your way across. What's the first one? I think -3, isn't it? I agree. Yes? Keep going. I want them all in order, starting from the left, going across. -3, and then this one right here. Which one? You with me, kiddo? You know you got it right in front of you. You can just look down, right? Missed one. Uh-huh. Yes, okay, now you got the hang of it, redeem yourself. Range, start with the lowest, work your way up. Yes. Yes. Good catch. I wondered if you'd catch that. You learned. And? 1. Function or not? Does it pass the vertical line test? Yep. You know what? I'll zoom in on these, and that way you guys can see better. Even though they're in front of you, it helps. Second graph, function or not? Let's do that first. Yes, I agree. This is a continuous. I'm not going to list them. This is going to be either between two values or everything to the right of, everything to the left of. Okay. In fact, I think because it's not going forever, it ends. This is going to be between two values. Domain, let's see. What's the furthest left this graph goes? -3. What's the furthest right this graph goes? It's in between, not touching, not touching. How can I tell it's not touching? What's our handy shorthand? Yeah? Hollow circles. That's a really nice handy shorthand. Easy to do, freehand or typing. Range. -3, less than, not touching. What? How high? I think that's supposed to be, let's put a dot there just to really exaggerate it. I think that's supposed to be exactly 4, but I couldn't quite get the typing thingy to, anyways. So Y, does it touch 4? Since I put that dot there and colored it in, it does. So, or touching 4. Nyunk. Next one, function or not? No, circles aren't functions. Too bad. Surprisingly tough to graph by a computer. Easy to graph by hand. Domain, range, 1, yeah? Touching, x, touching 1, 2, 3, 4, 5, between 1 and 5, including? Between 1 and 5 inclusive? 0, touching. Y less than touching 4? 4? 1, 2, yeah, 4. 5? 4 high, isn't it?
4 high.
Yeah. Scared me for a second there. Last one. Function. Assuming it continues the way it does, yeah, right? Passes my vertical line test, so yes. Domain. Oh, this one's got arrows, so now I got to think. Yep. Ooh, nice. You even used the math term, yeah. All reals. X, funky ER. All reals. Range. I think the same thing, because it goes all the way down and all the way up. So that's some quick review. We're going to talk about function notation today. So we're going to be talking about functions. Y, I wrote, is a function of x because y depends on x for its value. For example, if I gave you the equation y equals 3x, if I don't tell you what x is, you can't figure out what y is. So if I told you that x was 2, and this was our equation, and x is 2, what would y be? You're right, right? 6. Or in English, the point 2, 6 is a point on the graph. Or in today's lesson, in function notation, the function, when you put 2 in, results in 6 as an output. In fact, the y can be replaced with a symbol, and the symbol is this thing here, f bracket x, except you don't say f bracket x. You read that as f of x. That's how we're going to say it from now on. Or sometimes you'll say f at x. I'll almost always say f of x, where f is the name of the function and x is the variable used in the function. And this is called function notation. When you see f of x, in terms of graphing it, it really does mean the same as the y value. They're very interchangeable. But there's a reason why we're willing to write a little bit more here. F of x is more writing than just the letter y. And you'll see why in just a bit. It does not mean f times x. So every so often kids see an f and a bracket and an x, and they're so used to brackets always meaning multiply. This time it does not. This time it says f of x, where x is your input. For example, the function y equals 2x minus 1 can be expressed using function notation as f of x equals 2x minus 1. Complete the chart below. I could write y equals 4x plus 1. I could write it in function notation. If I wanted to write it in function notation, I would write it as f of x equals 4x plus 1. Same thing. I could write y equals x squared minus 5x plus 1. That's a curve. I could write f of x equals x squared minus 5x plus 1. If they gave me the equation y equals 2 to the power of x, where x is the exponent, and I wanted to write it in function notation, Ashley, I could write it as that. Why, Mr. Dewick? Don't write this next bit down. You don't have to use the letter F necessarily. We almost always, Jordan, start with F. Why would we write function notation starting with the letter F? It goes with the word function. But let's suppose, Alex, I wanted to put all three of these on the same graph and label them. If this was all I had, I would label the first graph with a Y, the second graph with a Y, and the third graph with a Y, or I would have to write out the entire equation, which is a pain. Supposing you said to me, hey, Mr. Dewick, graph all three of those on the same equation. Here's what I would do. I would call the first one f of x. I would call the second one g of x, and the third one h of x. And then when I labeled the graphs, whichever one I put a letter f on, you would know was this one. Whichever one I put a letter G on, you would know was this equation. Whichever one I put a letter H on, you would know was this equation. So it gives us more letters to pick from, to label from. I can go with I of X, although usually we don't use the letter I because it looks too much like a number 1. J of X, K of X, L. Start with F, we work our way around. Turn the page. Another way this is really handy is substitution. If f of x equals 3x plus 1, recall mathematically this is the same as y equals 3x plus 1. Supposing I want to tell you to, listen closely, put a 2 in where the x is right now. 10 words. Sam, that's way too much writing. If I say substitute a 2 in for the x, that's still too much writing. Replace every x with a 2, that's still too much writing. One way that function notation is a great shorthand is it lets us very conveniently give you an instruction on what to substitute in for the x. If I write f of 2, f bracket 2, what I'm really saying is where there used to be an x, put the number what? 2. Except I can write it with an F, a bracket, a number, and a bracket. 4 characters, not 10 words. It means replace x with 2 and then find the value. So if I said f of x was 3x plus 1, and I said find f of 2, that means replace every x with a 2. Oh, and evaluate. What is 3 times 2? What is 6 plus 1? What this means is that when x equals 2, y equals 7. That's a point on the graph. But in terms of, say, me giving you substitution instructions, function notation is great. It's about as short as you can make it. Oh, ready? With this same one here, in your head, find f of 5. Means put a 5 in for the x. 3 times 5 is plus 1. The point 5 comma 16 is on that graph. Are you ready? In your head, find f of 10. 31. It's even shorter to say in English than for me to say, stick a 10 in for the, I mean, even in English, it's a nice, faster way. A little weird at first, Brianna, I realize, but if you wrap your brain around it, it's nice if you get the hang of function notation. It conveys a lot of information. Oh, not only that, it also tells you a point once you've done the math. So when you say f of 10 was 31, that means 10 comma 31 is a point on this graph. Has to be. And it very easily allows me to use different letters to describe different equations. Example 1. I'm going to give you 2 functions. F of x is 4x plus 1. G of x is 7 minus x. Find the following values. A says f of 7. How do I know they want me to use this equation and not this equation? F. Again, lots of information, very conveniently. If they wanted me to use the other equation, what letter would they have used? G. Very obvious. Oh, and if they gave me a third equation, they can use an H or whatever. As opposed to, if we hadn't done that, if we had Y's in each of those places, you wouldn't know which Y I was talking about when I said Y, because they're both Y's. So you ready? F of 7 means 4 times 7 plus 1. Yes? In your head, without a calculator, what is f of 7? F of 7 equals 29. Is that what you said? Here's what else that means. Is on the graph. In fact, Sam, can you actually see, you can actually already see kind of hidden the point in that little line right there. Another nice thing, if I just write the function, the input, and the answer, I can also say, oh, that's also a point on the graph too. That's a lot of information contained in a letter, a bracket, a number, a bracket, an equal sign, and a number. It's very nice. G of negative 2. That means 7 minus negative 2, right? What is G of negative 2? 9? Or as a point, if I was graphing equation G, I know it goes through that. Get me a couple of more, connect them, and I've got it. Oh, and I know it's a line because there's no funky exponents or stuff. I wonder if we can maybe almost do some of the substitution in our heads. Let's try the next one in our head. F of negative 3 means replace every x with a negative 3 in function f. It's going to be 4 times negative 3 plus 1. 4 times negative 3 plus 1. So the point negative 3 comma negative 11 is also on that graph. Yo. Put a negative 3 in there. Right? It's okay. Mistake. And you've seen I make a bunch of those all the time, so no shame. Oh, I think we can do this one in our head. What's G of 7? Really? You can go 7 minus 7 in your head? Anthony, I'm so proud of you. So 7 goes with 0. Okay. More complicated equations. You may need a calculator. We'll see. I'm going to zoom in just a little bit. A. I'm going to go yoink like that. F of 2. What does that mean? What do they want me to do? What do they want me to evaluate? Replace every x with what? So it's going to be 2 squared plus 3 times 2 minus 5. Yes? 2 squared plus 3 times 2. 3 times 2. Let's do our bad math, right? It's going to be 4 plus 6 minus 5. So f of 2 equals 5, or as a point, 2 comma 5. Oh, by the way, Sam, this also works backwards. If you know that the point 2 comma 5 is on your graph, you know that this statement must have been true, that when you put an x of 2 in, you got a 5 out. Even if you don't know what the equation was, you can at least tell that part. G of 22. G tells me use function G. Replace every x with a 22, so that's going to be 22 plus 3. What is G of 22? What is 22 plus 3? 25. Square root. 5. Or as a point, this graph goes through 22 over, 5 up. which it does. F of negative 3, we'll have to be a little careful with negatives because that's when we make our mistakes. Means replace every x with a negative 3. It's going to be negative 3 squared plus 3 times negative 3 minus 5. Right? It's going to be negative 3 squared. What is negative 3 squared? It's going to be 9 plus, what's 3 times negative 3? Negative 9 minus 5. What is 9 plus negative 9? 0. Take away 5. By the way, I've told you your provincial exam has a non-calculator section. Could some of this, as long as the equations were reasonable, be on the non-calculator section? Could they expect you to do some of this math in your head? Yes. They're not going to give you something crazy huge. The fourth root of 193, but basic stuff. You get negative 5, yes? So what we're saying is f of negative 3 equals negative 5, or negative 3 comma negative 5 is a point on that graph. G of negative 12. That's going to be the square root of negative 12 plus 3. What is the square root of negative 9? Sorry? Ooh, he remembered. Can we solve it under the real number system? No real answer. And here's what else that tells you. 12 doesn't go with anything on this graph. Or, if we're talking about the domain, Brianna, 12 is not part of the domain. Now, here's the first time where we've started figuring out a domain without a graph in front of us. We've started saying, oh, sometimes the domain is determined by whether or not you can actually get an answer to a y value, a function, to go with your input. I can tell you right now, I don't know what the domain is, but it sure doesn't include negative 12. So, when we see f of 3 equals 5, Greg, we know the x value is 3, then the y value is 5. So to plot this on the grid, go right 3 units and up 5 units. That means, Garrett, I can now start to give you points in a different way. Instead of saying something comma something, I can say f of something worked out to something, and it's still a point. But in many ways, even though there's a bit more writing, it contains way more information, because what you're now starting to do, Amy, is link it to an equation. It says, for each state the coordinate point, and then place it on the grid provided. If f of 1 equals 5, what's the point that tells you exists?
1, 5.
1 over 5 up, that's where point A is. If f of negative 2 equals 3, that means negative 2 comma 3 is on this graph. Negative 2 comma 1, 2, 3, that's where point B is. What point comes out of f of 0 equaling negative 2? 0, negative 2. That means 0 left, right, negative 2 down. That's where point C is. Try D and E on your own. Yeah? Oh, Jordan, if instead of giving you this function statement and saying plot the point, could I give you the point and could you then say, I know what the function statement must have looked like? Yeah?
Yep.
Next page. Here's a graph. I don't know the equation. But I can tell you some of the function values because they gave me the graph. I'm going to reverse what we just did. So f of negative 2 equals blank. If it was a point, you would have said, right? Well, can you find negative 2 on the graph, please, for an x value, and then move up or down to see what y value it goes with? Here is negative 2. What y value does negative 2 go with? We're reversing what we just did. What would f of 0 be according to this graph?
2.
Yep. What would f of 3 be according to this graph? F of what works out to negative 3?
-4.
They're talking about that point right there, aren't they? I guarantee you'll see this question on the provincial. They love this question. They love this question. And you know what? I've seen provincial exam specs. Kids struggle on this. And this is where at the beginning when I said maybe this is kids overcomplicating it. I think they are. Or maybe they get mixed up which one's X and which one's Y. But hopefully you've been able to keep that straight by the way we built up to this. I hope. All right. Let's give you an application. The distance an object travels when it's thrown in the air is written as, you know what? Instead of F, how about D for distance? And instead of X, how about T for time? And now we can say in terms of physics and science, D of T, distance as a function of time, is equal to 20T minus 5T squared, where T is the time in seconds, and D of T is the distance in meters. Find D of 0. What's that saying? It's saying wherever, I'm not going to say X because there's not an X, there's a T. Wherever there used to be a T, replace every single T with what? 0. That's going to be 20 times 0 minus 5 times 0 squared. What is D of 0?
0.
Very good. Oh, that's important. This graph goes through the origin. I don't know what it looks like, but I can tell you it goes through 0, 0. What would D of 2 be? Replace every T with what? $40. There's the multiplication part. What's 2 squared? I think it's 40 minus 20. Yeah? D of 2 equals 20. After 2 seconds, how far has this object traveled? 20 meters. Oh, and after no seconds, how far has this object traveled? Nowhere. It should go through 0, 0, now that I think about it that way. Part C, if D of 4 equals 0, is D of 4 0? Let me see. It's not quite. Close. Oh, yeah, it is. Yeah. Complete the following sentence. If the time is blank seconds, then the distance above the ground is blank meters. What does that sentence tell you? If D of 4 equals 0. If the time is, how many seconds are we talking about here? Well, it's either 4 or 0. Which one? Go look at the original statement. Which one of those was time in the original function? What letter? T. And I think we put the T in brackets there. We put the 4 in brackets there. I think that's the time variable. I think we're saying if the time is 4 seconds, then the distance above the ground is what?
0.
This means the object has? Doesn't it mean it's landed back on the ground? Because it was above the ground. At one point it was 20 meters up in the air. But apparently after 4 seconds, I guess it's come back down. Little physics for you. Function notation. What's your homework? Take home quiz. And then give you a bunch of these to try. If you want to try evaluating them in your head, I think that's okay. Check your answer to make sure you're doing it right. You may need your calculator for some of the more complicated ones. Oh, here's 3 functions, f, g, and h. Okay. Number 1, all. Oh, take a look at j on the next page. How do you think you'd do that? What do you think they want you to do there? I think get an answer for whatever f of negative 2 is. Get an answer for whatever g of 2 is. Get an answer for whatever h of 9 is, and then add those together. Oh, you mean that's a shorthand way where I can also tell you to add equations together? Yeah. It's very nice. I haven't done number 2. I'm going to see if you can figure it out. If not, I'll talk about it Monday. Number 3 we did, except here I'm giving you a graph instead of the actual function graph equation. For A is fair game, B is fair game. C, F, I haven't talked about. I'm curious to see if you can figure it out. Five is good. 6, meh. 7 is good. Yeah, 8 and 9. And try 10. Again, 10 is going backwards. It's saying if I tell you what the function worked out to, can you figure out what the input value had to have been? See if you can figure that out. If not, I'll talk about that one on Monday as well. So you got about a half an hour. Get the take-home quiz done for sure, and then start whittling away at the homework.